In this video, we're going to continue with counting techniques, and we're going to talk about the addition rule and the inclusion-exclusion rule. So let's start with an example, and this example just requires you to know that a standard deck of 52 cards has 4 cards of each type, 2, 3, king, queen, ace, etc., and 13 cards of each suit, and the suits are hearts, diamonds, clubs, and spades. So here's 2 quick examples. One, select one card from a deck of 52 cards. In how many ways can the card be a queen or a jack? And 2, select one card from a deck of 52. In how many ways can the card be a queen or a heart? So just think about these 2 questions very briefly, and then we'll talk about them together. Okay, in how many ways can the card be a queen or a jack? Well, there are 4 cards that are queens, and then there are 4 cards that are jacks, and in total there are 4 plus 4, there are 8 cards that are queens or jacks. What about in how many ways can the card be a queen or a heart? Well, we have 4 cards that are queens, and we have 13 cards that are hearts, but one of those cards is the queen of hearts. There's one card that is both of those things. So one way we could approach this problem is just to say there's 4 cards that are queens, there's 13 cards that are hearts, but I want to subtract away the one that is both a queen and a heart because it was counted here and it was counted here. So in total, there are 16 cards that could be queens or hearts in this deck of 52. Another way that you could do this is to just say, okay, there's 4 cards that are queens, and there are 12 cards that are queens but not hearts. We just have to keep that in mind, and that would still get us our 16. But this way of thinking about it gives us what's really the inclusion-exclusion principle. So this can really be called the addition principle or the inclusion-exclusion principle, but this is sort of the more nuanced version of it. That if we want to figure out the ways that one event or another can happen, we add the total number of ways that the first event can happen plus the number of ways the second event can happen and subtract off anything in the intersection that was double counted. So if event A can happen in cardinality of A ways and event B can happen in cardinality of B ways, then the number of ways that A or B could happen is A union B, the cardinality of A union B, this is A or B, is equal to the number of ways that A can happen plus the number of ways that B can happen, and then subtract off their intersection, the number of ways that both A and B occur simultaneously. Why is that? That's because any element that's in the intersection was counted once for being in A and counted a second time for being in B. And subtracting off that intersection means that X is counted only once and not twice. So we're subtracting away the things that were double counted. So something to notice here. So we previously did the multiplication rule or the multiplication principle, and notice that was when something was in steps or had an and associated with it. So I'd like you to associate multiplication with and. This occurs and that occurs. We roll a die and flip a coin. Versus addition, I'd like you to associate with or. Does this event occur or does that event occur? So here are 2 more examples for you to try out, and then we'll talk about them together. So first, a 20-sided die is rolled. In how many ways can the die be more than 15 or an even number? And next, let's say that we roll 2 20-sided dice, die 1 and die 2. In how many ways can these die either both be greater than 15 or both be even numbers? So I'd like you to pause and think about these for a moment. A 20-sided die is rolled. In how many ways can it be more than 15 or an even number? Let's let A be greater than 15, and let's let B be the event that the die is an even number. Then the number of ways that A or B can occur is equal to number of ways A can occur plus the number of ways B can occur minus the number of ways that both A and B can simultaneously occur. So here, how many die sides are going to be greater than 15? 16, 17, 18, 19, 20. There's 5 of them, plus number of even values on a 20-sided die. 10 of them are even, minus, now where are the cases where the die shows both an even number and a number greater than 15? That's 16, 18, and 20. There are 3 of those. So the total number of ways that this can occur is 12. 12 ways this can occur. Next, what if we're rolling 2 dice? And what's the probability, or in how many ways can they both be greater than 15 or both be even numbers? So let's let G be both greater than 15 and E be both are even. So then the number of ways that G or E can occur is, again, using the inclusion-exclusion principle, the number of ways G can occur plus the number of ways that E can occur minus the number of ways that both can occur together minus the number of times that these events were double counted, both in G and in E. And so let's think about this. So number of ways G can occur. So this is really now a list of length 2. We've got number of choices for what the first die is and number of possibilities for what the second die is. And so if they're both greater than 15, there's 5 ways for the first die to be greater than 15 and 5 ways for the second die to be greater than 15. Now that's an and, so we should be using the multiplication rule there. So the number of ways for the first to be greater than 15 is 5, and the number of ways for the second to be greater than 15 is also 5. So the number of ways for the 2 dice to both show a number greater than 15 is 5 times 5. What about for both being even? Again, there are 10 ways for the first die to be even and 10 ways for the second die to be even. And then we want to subtract off the number of ways that both of the dice follow both of these rules, that both are even and greater than 15, 16, 18, or 20. There's 3 ways the first die can be greater, that can satisfy both properties, and 3 ways the second die can satisfy both properties. So this is 125, or this is 25 plus 100 minus 9. This ends up being 116 is the total number of ways this can occur. So we can apply these counting techniques to probability. The probability of an event, if we're talking about classical probabilities with things that are equally likely outcomes, like die rolls and stuff like that, then the probability of an event is the number of ways that the event can occur divided by just the total number of ways the experiment can occur, or this is also called the sample space, the number of elements in the sample space. So in our case, if we were talking about the probability of the event we just talked about, there are 116 ways that the 2 dice could either both be greater than 15 or both be even numbers. Out of the total number of ways that 2 dice can be rolled, again, this is a list of length 2. There are 20 possibilities for the first die and 20 possibilities for the second die, so that's multiplication. And so this is 116 out of 400 would be the probability of that event.